Hello, today we are solving a problem on the topic of equilibrium of solid bodies and will consider an interesting question. A person is holding a baseball weighing 1.42 newtons at a distance of 34 centimeters from the elbow joint. Here this joint is marked with a point 0. The bicep attached at a distance of 2.75 centimeters from the elbow is the force F, applies a force of 12.6 newtons on the forearm directed upwards. Consider the forearm and hand as a uniform rod with a mass of 1.2 kilograms. This is essentially a straight line. So the question is, calculate the resulting torque acting on the forearm and hand using the elbow joint as the axis of rotation. If the resulting torque obtained in the first part is not zero, in which direction will the forearm and hand rotate? Thus, we are faced with a task from the field of biomechanics, as we comprehend that our limbs function as specific types of levers, which we use for performing certain mechanical actions, but in this case, the action is aimed at keeping the ball in a certain position. So here we will examine the mechanics of this equilibrium from the perspective of calculating moments of force. I remind you once again, the point of rotation will be considered the elbow joint, which is point O, or 0. And accordingly our task is to calculate the total moment resulting. The moment created by all the forces acting here relative to this point. Let's first consider the three forces that do not pass through the joint itself, because it is clear that there will also be some support reaction at work here, which holds it all together. But it will definitely pass through the axis of rotation itself and has no moment. Therefore, here we have a moment with three forces, which we depicted in the diagram. These are the force of the bicep, the weight of the ball itself, and additionally, the weight of the limb itself. Now, the main thing is to figure out which moments turn this object and in what direction. To clarify, let's recall what we mean by this definition. We establish the clockwise direction and observe which forces rotate this object in relation to it. It is evident that the weight of the limb itself and the ball, its weight, rotate this joint clockwise. Accordingly, the force of the bicep rotates it counterclockwise. Therefore, we have two moments rotating the body clockwise and one moment rotating it counterclockwise. And so, our task is to calculate the resultant moment of all these forces. For this, we will naturally recall that moments, those that rotate the body clockwise, we take with a negative sign and counterclockwise with a positive sign. First, let's write the positive moment, which is the moment of force F. I remind you that the moment of force is the product of force on her shoulder. And here we will see that the shoulder is precisely the segment D2 that we need, which is the distance from the joint to the point where the bicep is attached. Next, now the negative moment involves gravity. That is mg multiplied by, and here it's important to remember that if we were given a hint to consider the forearm and hand as a uniform rod, the gravitational force acting on a uniform rod is located at its midpoint. Therefore, the distance from the elbow joint to the midpoint will be half of d1. Thus, this is the lever arm of the gravitational force. And accordingly, the weight of the sword itself will also work with its shoulder. But here we can see the full distance from the point of rotation to the line of action of this force. This is simply d1. So we have derived the formula for the total moment. Now, let's proceed with the calculation. So, the strength of the bicep is this, and multiply it by its shoulder. So the bicep force is 12.6 multiplied by its lever arm, which is 0.0275, then minus the mass 1.2 multiplied by 9.81 and multiplied by d1 divided by 2, which is 0.17, and minus the weight 1.42 multiplied by 0.34. And so we substituted all the data, and accordingly we get the output value is approximately minus 2.13 hundredths of a Newton multiplied by a meter. And so what does this answer tell us? First of all, we obtained a numerical value for the moment different from 0, which in this case indicates that this shoulder, let's say, is not in equilibrium, and thus some specific rotation begins. And now it's important to understand in which direction this joint will rotate. That was the second question of this. Considering the fact that we got a negative value in the answer, it indicates that the total clockwise moment has become greater than the counterclockwise one. The arrows, therefore, this body will start moving in this direction with a certain acceleration. And accordingly, then the acceleration can already be calculated, for example, through the second law. Newton's law states that if we know the resultant moment, which we have found, then we can calculate the moment of force based on the fact that several forces are acting on the same body, considering the different directions of the forces applied. And with that, our session has come to an end. See you in our next lessons. Goodbye, everyone.